Hey everyone, it's Alex from EDD Academy, and today we're going to be looking at combining rules practice for Unit 3. So before we actually get into applying all of the rules we've learned to various problems, I want to see if we actually remember those rules. So let's start with the derivative of a constant rule. If you remember, this rule said that d dx of any constant c equals 0. If you want a further explanation on this, just go watch EDD Academy's Basic Differentiation Rules Part 1. Moving on to Rule 2, the power rule. The power rule says that the derivative of any function x to the power of n is n times x to the power of n minus 1. The derivative of constant multiples rules says given a function f of x and you multiply a constant c to it, then the derivative of this whole thing is c times the derivative of that function f of x. You just pull out this c. And finally, the sum and difference rules. This says that given a function, or two functions, f of x and g of x, and we are adding their derivatives, so we're taking the derivative of a function that comes about by adding two separate functions, this derivative equals the derivative of f of x separately plus or minus the derivative of g of x separately. Moving on to some of the rules we looked at in Unit 3, we have the product rule. The product rule says given two functions, f of x and g of x, and we want to find the derivative of their product, we can write it as f of x times the derivative of g of x plus g of x times the derivative of f of x. Its pair rule, the quotient rule, says that given a quotient of two functions, f and g of x, then their derivative is g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. And finally, the chain rule. The chain rule says given a composite function, f of x, big F of x in this case, its derivative is f prime of g of x, so the derivative of the outside and keeping the interior function, the inside function the same, times the derivative of g of x, or the derivative of the interior function. Once again, this should all be pretty much review for you and a good primer to get into some examples. So our first example asks us to find the derivative of x to the fourth times sine of x times cosine of x. Right off the bat, you can see that this is very clearly a combination of the rules we've learned so far, and specifically, it uses two cases of the product rule. And we'll look at those cases in a second. So we have x to the fourth times sine of x, but the function doesn't end there. We also multiply by cosine of x at the end. And we just looked at last slide how to deal with the product rule. And what we need to do is extend the arguments that go into the product rule to fit this three argument form. So let's say we're given a function, or we have to find the derivative of the product of three functions, f of x times g of x times, let's say, j of x. Then the derivative of this function is f prime of x times g of x times j of x plus f of x times g prime of x times j of x plus f of x times g of x times j prime of x. It follows the same pattern, we just have that extra term there. So we can apply this pretty easily to, well, to this function right here. So in this case, f of x is x to the fourth, g of x is sine of x, and j of x is cosine x. So I'm going to actually write this on the next slide. So in this case, we have the derivative of x to the fourth times sine of x times cosine of x plus x to the fourth. Now the derivative of sine of x times cosine x plus x to the fourth times sine of x times the derivative of cosine x, pretty much fitting the exact same form we looked at here. Now we can just, well, compute these derivatives. So the derivative of x to the fourth is 4x cubed, and then we have times sine of x times cosine of x, and plus x to the fourth times the derivative of sine of x, and the derivative of sine of x is cosine of x, and times cosine of x there, and finally x to the fourth times sine of x times the derivative of cosine x, which is negative sine x. If we simplify this a little bit, we have 4x cubed sine x cosine x plus x to the fourth times, this comes out to be cosine squared x, and this is, if we pull this negative out front here, we have minus x to the fourth sine squared x, and that is our derivative. Taking a look at example 2, which asks us to find the derivative of cosine squared of x to the 7th. This is another combination of rules, but in this case, we're using the chain rule. And it looks like the chain rule 2 times. 2 cases just like last time. So to make this a little bit easier, we can rewrite this function here, this whole thing, as the derivative of cosine of x to the 7th quantity squared. That makes using our rules a little bit easier. So if we use the power rule, we have 2 times cosine of x to the 7th times, well, this is our interior function in this case, cosine of x to the 7th, not just x to the 7th, so we multiply by the derivative of cosine of x to the 7th, which is negative sine of x to the 7th times the interior function of this interior function. It's a little bit confusing, but so times the derivative of x to the 7th, which is 7x. And that's it. That's our derivative. Our final example asks us to find the derivative of the square root of the tangent of e to the x. This is another case of using the chain rule plus the power rule. If we write this to make it a little bit more convenient, exactly like we did in the last example, we have, well, this square root can be written as the same power to the 1/2 power, or the same function to the 1/2 power. So this quantity tangent of e to the x all to the 1/2. So if we compute this derivative, we have 1/2 times tan of e to the x all to the negative 1/2 power. This is the power rule. The power rule. So you can see we brought this 1/2 here. This 1/2 is the n in the power rule in our case. So we bring this 1/2 down and take the interior function to 1/2 minus 1 power. So to the negative 1/2 power. And we need to not forget this interior function. So times, just like we did in the last example, times, well, the derivative of tangent is secant squared x. So secant squared of e to the x. And the derivative of e to the x is just e to the x. So the first chain rule is the first step of the chain rule is taking the derivative of this tangent and keeping this constant, and then we multiply by the derivative of e to the x. But the derivative of e to the x is just e to the x, so we end up with this statement. If we simplify this a little bit, what to the negative 1/2 power means that we're going to have a square root on the denominator of the function. And this 1/2, this coefficient, means we're going to have a 2 times that square root function on the denominator. And this is our numerator, because this doesn't have any negative exponents. So if we rewrite this as the numerator, so secant squared of e to the x times e to the x all over 2 times the square root of tangent of e to the x. And that's our derivative. That's it for combining rules practice. We'll see you in the next video where we'll talk about higher order derivatives to close out chapter 3.